Hi, this is A Plus Tutoring, and in this session I'll be having a session with the student on organic chemistry reactions, substitution reaction, addition reactions, and elimination reactions. Thank you for joining us, and would like any feedback on what you think of the session in the comment section below. Since this is a session with the student, if there are things that you did not understand or you'd like more explanations in, please do let me know in the comment section below. Now let's see what happened from here to here. What did we add? What did we remove? Try to draw it, ne? Okay, so let's draw this one, right? We have a C, and then we are told we have a double, right? So I now have my H, okay, I'll try avoid writing H. Is your high?
Yeah, that's right.
Okay, then here I have 1. Okay, so now I have this, right? And then they added something, but I don't know what that is yet, right? They added this something, this X, and then what did it make? It made this 1 2 3 1 and Cl, and then 1 2 3. So what do you think was added here?
A halogen.
A halogen. Okay. What kind of a halogen?
Hi.
Hmm?
Oh, hello, okay.
No. What kind of a halogen? What's X? Here's the thing. Here's what we had before, right? Here's what we have after. So what do you think we added for us to get this? Count off everything. Count your H's. How many H's you have here, how many H's you have there, how many whatever you have here, and how many whatever, and see that which was not here and now it's there. We have an extra hydrogen, right?
And we don't have one.
Okay, meaning we now have also a Cl. We didn't have it, Angesh.
Yeah.
That means that here's what I have. This is what they added.
Mm-hmm.
So meaning X should be HCl.
Wait, that line does that just represent what was added?
Yes, that line represents a reaction. So they may also ask you what kind of reaction is. So now I know what I added, right? I now have to know what kind of reaction this is. What is it called? What is this reaction called, where I come from an alkene, right? And I go to a what? A haloalkane. What's the name of this one? It's called an addition reaction, right?
Yeah, oh yeah.
Why? Because I'm adding something. I'm not removing, I'm adding something. But now they'll be like, what kind of addition reaction is?
Is it going to be elimination?
No, remember that we are adding. So it's not an elimination. Elimination is more when I'm now moving from an alcohol to an alkene. I'm removing something. That's now an elimination reaction.
So substitution. What?
I did not substitute, I added. I'm addition reaction, right? Remember, addition reaction, I am starting with 2 things, but I'm ending with what? 1.
Okay.
So it's adding 2 things to end with 1 thing. That's addition reaction. Elimination reaction is me starting with 1 thing and then I come and get 2 things.
Okay.
And then substitution reaction is maybe I'm starting with 2 things and I'm still going to end up with 2 things. Because maybe in place of an H that was this side, I put a Cl, and then where that H came from, it took that. You get it?
Oh, yeah.
Okay. So now, the types of addition reaction now. We have hydrogenation. Hydrogenation is whereby we're adding what? H2. Right?
Mm-hmm.
But remember, since it's addition, I'm starting with 2 things, I'm ending with only 1 thing.
Oh, because they're becoming one.
They're becoming one, yes. And then now, a halogenation. Halogenation is whereby I'm adding a what? A halogen. But I'm adding this double halogen, the Cl2, the Br2, like it's just a halogen. Okay. So now, because it's an addition, I have 2, I'm going to end up with 1, meaning that's why I end up having a compound that has 2 Cls. Because I added it, and it has to be 1, meaning that all of them have to join. And then, because they have joined, it then breaks that single bond to make that double bond to make a single bond, because the other bond was now taken by Cl, right?
Wait, can you say it again?
Okay, so now because I'm adding, right? Like for example, this one. Let me do that. I had this, right?
Mm-hmm.
And then I said plus what? H2, right?
Yeah.
It's gonna break this single bond, in this double bond, into a single bond. Why? Because this H is now gonna have to come and join here, meaning it took away here. Remember, I'm only supposed to have 4. And then the other H is now going to come and join here, meaning the relationship between these 2 C's, I've broken it, and I now have 1 instead of 2.
Okay.
Which is the same thing they would have done here, because we had a double bond here, right? But now I'm introducing a Cl2. So one of the C's here, it's going to go with the Cl, meaning I broke the bond here, and then the other goes with the other Cl.
Okay.
Okay.
Yeah.
So, and then we have what we call a hydration, right? It's also an addition reaction, right?
Yeah.
So, hydration needs us to have what we call a catalyst. They will ask you this catalyst. The catalyst here, it's a concentrated sulfuric acid. Why is it concentrated? It's because it's not going to take part in this reaction. It's just there to make sure the reaction takes place, but it's not going to be part of the reaction.
Okay.
Okay, that's why in this case, in addition reaction for hydration, we use a what? A concentrated sulfuric acid. So when you actually write this reaction, it has to have that H2SO4.
So that will be what's the
It's hydration. You're adding water in this case.
Oh, sorry.
So since you're adding water again, remember, we now break this bond, right? So we now have CC, and then I had an H and H and an H and H here, right?
Yeah.
So because I had H2O, this H2O separates into an H and an OH. Now this H comes and joins here. I now have the H. This OH moves together, comes and joins here. I now have my OH. So now it then makes it an alcohol.
Wait, why does the H move together?
That,
we're forming an alcohol. Okay.
remember, hydrogen bonds are stronger, right? So I cannot separate the H and the O.
Oh, so you just move together
as an OH, and then the other remaining H goes on the other one.
Okay.
Okay, and then I have the one we were dealing with now. It's called hydrohalogenation. Why is it hydrohalogenation? It's because you're adding an HX. You're adding whether it's a HCl, HBr, HI, but it's an HX, meaning it's H with a halogen. Yes.
Yeah.
That's the one we're dealing with, so that the other one, the H goes on the other, right? And then the halogen goes on the other. That's why in the question we were dealing with, we did find that I had an extra H here, and which I didn't have here. And then I also had the halogen, meaning this would be hydrohalogenation.
Oh, wait, what? Oh, because it's H.
Yes, it's HX.
Okay.
Okay. Now let's come.
No, you can get it.
Okay.
Then
Now we go to your elimination reactions, right? So now with elimination, I started with this one, they call it dehydrohalogenation. Why? It says it in the word dehydro.
so we're
What are we removing?
so we're removing H
HX, because you see it has that hydrohalogenation, meaning in hydrohalogenation it's my HX, and since this time it's saying D, that means that I'm gonna have to remove something, that is, I'm gonna have to remove an H and an X from this compound. Because remember, Uti, the reason why we added this is a base, right?
Which one?
This, the NaOH. Remember, anything OH is a base, right?
Yeah.
So this is a base. The reason why we added it in this case is, remember, anything HX, it's an acid. So we don't want to end with an acid in our products. That's why we have a base, so that the base can react with the acid, and then this one takes the X and that one takes the H and becomes water. Because otherwise, if I remained with this in an acid, automatically it's gonna react back again to form that, like it will keep just reacting.
Oh yeah.
That's why I need to have a base. The base is there to separate the two, because how would these separate otherwise without a base? So the base is there to actually take out the H and X.
Okay. Yeah. That's it. We didn't. Wait, why we added more? I'm saying that way because I understand the H. Wait, so now, how did the NaOH? Okay, I understand it NaPr, but how did we get up water?
Okay, how we got water? Remember that once I take out here, I took out what? HBr, right? And then here I have NaOH. So if Br goes with Na, what am I remaining with?
H2O.
Yeah.
Oh.
Because remember, an acid plus a base gives me water and a salt. So this is a salt.
Oh, because we put Na, A, and B on it, we were left with OH. Oh.
Okay.
Okay. Yeah, I see.
Okay, and then now we move on to dehydration. You already see by the word hydration. You know hydration, when we're adding what? Water.
Water.
Right? So since it's D, that means we are removing water. That means at the end of our products, we're supposed to have water.
Water.
So this one, we normally come from an alcohol and then it removes. We now have an what? An alkene. Remember, an alkene is the double bonded one.
Yeah.
Okay. Same when we go to dehydrogenation. What is hydrogenation?
Hydrogenate is when we with the when we add hydrogen.
Yes, hydrogenation is whereby we added hydrogen, which is our H2. So in this case, we are just removing H2, and then we have an alkene. So now this is where, remember this part, because they will ask you, they won't put it for you in the diagram, they'll now ask you, good, what is needed, like what are the conditions that are needed for this reaction to take place. So when they ask for conditions, that's where you mention, good, okay, this condition needs a catalyst, like for example PD or nickel or PT, and then for the other ones you'll be like, okay, this, like for example, they ask dehydrohalogenation, you have to say this reaction needs 1 heat, 2 an ethanol, 3 a base.
You can ask that?
Yeah. So you need to go to your reactions and get to know the conditions of each of these reactions, because they will ask you what are the conditions for the halogenation for it to take place. Now you need to know that I need a base for it to take place, I need heat for it to take place,
and ethanol.
and ethanol.
Bro.
Of which ethanol just acts as a catalyst because it's not part of the reaction, you see.
Oh yeah.
Okay. Here we now had our haloalkane, right? We are now moving from a haloalkane to an alcohol, right? So what I want you to do is now you draw the same haloalkane we have. Let me erase this. So we now draw the very same haloalkane we have, but because it now says that it doesn't have the Cl anymore, because remember an alcohol doesn't have a Cl, right?
Yeah.
So meaning I'm just, in place of Cl, I'm putting OH.
OH.
So what conditions, like what do I need to do for me to end up with something like this? What reaction could it possibly be that I end up getting an OH? So with substitution, I am removing something to form something else. Like in this case, you had something like this, right? This is hydrolysis, where you're adding water. We already had our X, right? We added water. And we ended with an alcohol.
But if they ask us about hydrolysis, you just say that addition of water in saturated compounds.
Yeah.
Okay.
Because it can even be, I'm trying to think if we can add hydrolysis to any other compound. No, I think it's mostly to haloalkanes, because those are the mostly saturated ones. Or you can also add water to an alkane itself. Like alkane, it's saturated, right? Plus H2O will give, remember we are substituting. So when we're talking of substitution, I'm removing A to put B in place of A.
Okay.
So I have, for example, if I have something like this, I had A here, right? I'm now removing this A and I'm gonna put B, but still everything else is still the same. This is called substituting. So in this case, you're working with a haloalkane or an alkane. For example, if I have something like this, right? You see it's an alkane. And then I add water. Because I've added water, that means that one of these H's, I'm going to have to remove it and put what? OH. So meaning the H that I removed will go with the H that is remaining in here, meaning I'll have a product of that plus this.
What?
But in this case, since I have a haloalkane plus water, right? A haloalkane, it's the what? The C, and then the X, right? I'm gonna remove the X, and in place of X I put OH. And remember that there was another H in the water, right? Because it has two, and here I only have one, meaning that H that's remaining will go with my X.
Okay. Yeah, I see it. Yes.
So this is also the same as here. This one, the halogenation. This one is also called halogenation. You're adding a what? A halogen. But because we are adding, remember the other one, the other halogenation we were adding it to a what? An alkene, right? That's why it became an addition reaction. In this case, it's a substitution because I have an alkane, of which an alkane, all the bonds are taken care of. So I'm going to have to remove this to put the halogen. And then that I removed now has to go, and because I had two halogens, and then now I removed an H, right? The H now goes and be with the halogen. So now I have a haloalkane plus a halogen with the H.
Yeah, okay. That makes sense.
You get it?
Mm-hmm.
Okay, so that's what happened in this question, whereby we went to an alcohol, meaning we had to add what? Water.
Oh, because an OA H that was left the other side.
So meaning that our other product, we have alcohol plus what? Our HCl, right? Okay.
Oh, H, yeah.
Because the H on the water took with the Cl, right? Okay. Now that we have an alcohol, and then we put it under saturated H2SO4. And then it gives us an alkene. What happened there? How many? 1, 2, 3, right?
Yeah.
And then I had, you see that this one, it's trying to tell me that this is position 1, this is position 2, meaning on position 2, that's where I had my Cl, right? So it now goes, and then, meaning on position 2, it's now the same place I'll have what? OH, right? Oh, and another thing I didn't mention, when we're doing addition reaction, for example, you're adding, like here we added the HCl, right?
Yeah.
You may have a question on why didn't the Cl go on this one, because it's also double bond, right? This one already has 2H, so it's gonna attract the H more. This one had 1H, so it's weaker to attract the H, so it will take the Cl. It's more of, if you move to a new school, if you have a chance to move to a new school right now, you would choose to go to a place that has more of your friends than where you don't have friends.
Oh, to that. Okay.
So an H is moving right from the HCl. It sees 2 of its friends here. It goes there.
Okay.
Yeah. Okay, so this is the alcohol we had, right? Now from this alcohol, we then had what? What happened? What did I remove?
You removed the
I removed what?
hydrogen
And
an alcohol.
what's the alcohol called? The one you're saying I removed H and what?
Oh, wait, it was H and OH.
And what is this?
What?
Yes, so meaning I'm removing water, meaning it's what? Dehydrogenation.
Yeah.
So this is a dehydrogenation. Okay. Okay, now again, I'm now moving from this, because this one was Y, right? Now let's do Z. Z, I'm moving from this, of which this one is the same as the alcohol, but without the OH, it had a Cl. I'm moving from this to this. What did I remove?
Wait, from that we removed. Wait, from which one to which?
From this to the alkene, which is this one here, to this one here.
We removed the chlorine.
The chlorine, okay, what else?
And a hydrogen.
And a hydrogen. And what is this process of removing this called?
Halogenate.
Yes, dehydrohalogenation.
Oh, I think I just need to throw it in.
Yeah.
Yeah.
So now you have done everything. You saw draw it, and then that's how you see it. Now these questions are not asking what type of reaction it is, which we did, the structural formula and the name for the alcohol. I want you to do these ones on your own, and then you send me the answer school WhatsApp.
Okay, what people was it?
I can send it to you now.
Oh, okay.
Okay, and then now you see here which says name the inorganic reagent. An inorganic reagent, now it's part of the conditions. You see now 2 reaction conditions needed. Those are the, do I need heat, do I need yeah, those kind of conditions. And then now here where they say that write a balanced equation for the production of the alkene using a structural formula, right? If they say using a structural formula, you're gonna have to do what we're doing here, this one, where you actually draw the thing. You draw and then you say whatever you're adding, if you're adding it with something, and then now you have your arrow. On the arrow, that's where you put your conditions, like you saw here where they were doing the H2SO4, right? They put it on the arrow. Let me go back to the notes. Okay, where if we had heat, you'd have a triangle underneath, but here they didn't put it. Let me just go somewhere, like you do it like this, but then this one it's half structural in a way. So you there would want the full structural formula where you literally draw everything, and then you have the arrow. If it's heat, you have a triangle underneath, or you can actually just write heat, and then you write anything else you have. If you have another agent like the H2SO4, you write your H2SO4 on top. This is showing that I need these things, but then the H2SO4 is not gonna react with anything here. It's just there to make sure that the reaction happens.
Okay.
So these will be your conditions, and then you write all your structural formulas and balance it to show that, okay, this, it will make that. And make sure you count. Remember, you're gonna count, right? To say if this side I had 1 2 3 H 4 5 6 7 8, this side I make sure I have to have 8, meaning I'm gonna count 3 4 5 6 7 8, so it's balanced. This is the end of our session. Thank you for watching. Please do like, subscribe, and follow for more.